2.5 years in, and I've still not learned about the unmute button. So with apologies to those on Zoom, what I was saying, it is wonderful to greet you all, to welcome those back into the room here at CBL, and to welcome those of you who are joining via Zoom. This is the first of our autumn 2022 Science for Communities lectures. And we are looking forward to an exciting series of 5 lectures, and I'll tell you a little bit about that as we move forward. For those of you on Zoom, this is being run as a Zoom conference, so unfortunately you won't be able to unmute and ask a question. You will be able to set something in the chat box as a question, and I will attempt to answer it. And for my daughter, who I know is online, I do not want to see, do crabs think we walk sideways? So I will start by remembering to share my screen, and we'll get going. So you should in Zoomland be able to see the shared screen. And I will start, if I can find where the pointer has gone. Talk amongst yourselves for a second. There we go. I will start just by saying thank you. This has been a dark time for many of us. We have been cut off from our social networks. We've been cut off from family and friends. But I will say this community has reached out to us throughout this pandemic, have made us know that you still believe in what we do, the work that we do, and still support our staff, and that has meant a great deal to us. I can't give this presentation without recognizing 2 people who will be missing from this audience tonight. The first one is Bernie Fowler, for whom this building was named. Bernie died a little under a year ago and was a real champion of the environment. He produced a movement by himself of clear communication that changed the political landscape in this state, and we owe a tremendous vote of thanks to him. The other one is Dick who was a long-time attendee of all of these presentations. Dick passed away sadly a little over a month ago, and we will certainly greatly miss him, but we hope his wife Sue is joining us tonight. So I said this is the first of 5, a little bit of advertising at the beginning. Here are the 5 that are coming up. We decided for the series back in person, we would come back with the greatest hits. So we're having crabs tonight. We've got sturgeon next week. For those of you who've been following the news, there has been a plan to put a huge sturgeon aquaculture facility on the eastern shore. Dave Secor, the speaker next week, has been doing a great deal of the work to assess that effort. The following week, Chris Rao will be talking about diamondback terrapins, fear for the turtle. The issue here is climate change. Terrapins have an unusual sex determination in that their sex is not determined genetically like ours is with chromosomes. It's determined by the temperature at which the eggs incubate. And so as the temperature of the sand increases, the sex ratio of terrapins is changing to an increasingly female-dominated ratio. And there's concern that it will become too female-dominated, and the overall capacity of the population to be sustained will go down. The fourth of the 5 is Jamie Tester talking about bottlenose dolphins, the results of our Dolphin Watch program. And last but not least, Dr. Walter Boynton, who's an emeritus professor here, who's been working on the Bay for 50 years or more, will be talking about his experiences and where he thinks we should be going for the future. So that's what's coming up. Tonight, I want to give you a very brief introduction for those who don't know about us as to who we are. We are the Chesapeake Biological Laboratory, part of the University of Maryland Center for Environmental Sciences, one of 12 institutions within the university system of Maryland. I like to say we are driven by environmental intelligence. If you were thinking of taking over a business, you would undertake business intelligence. You would look at their spreadsheets. If you were thinking of invading a foreign country, you would undertake national intelligence. You would be interested to know in their defensive capability. If you want to do work in the environment, if you want to protect, manage, and sustain the environment, I would argue we need to do environmental intelligence. And we do that around the world. Although we are based here in Maryland, we have impacts around the nation and around the world. We were founded by a remarkable man who, like me, liked to wear three-piece suits, called Reginald Truitt. He was a Renaissance man. I've told stories about him at many of these first lectures. He was trained as a fighter pilot in World War I. He lived to be 100 years of age. He was responsible for setting up Chesapeake National Seashore. He married the governor's daughter after having rejected the daughter of the ambassador of France. And this was a remarkable person. He also took the University of Maryland to their first national championship. I want to have a flag here. I can hang it from a ceiling somewhere. And he also developed what we would now call an ecosystem-based approach to science, to environmental science. And that was in 1925. And I will come back to that point at the end. We do a remarkable range of research in the 95 years since we were founded. We've been monitoring water conditions in local creeks for over 40 years now. As I mentioned, we've been working on diamondback terrapins. For those of you who have walked past the front of the lab, you'll see lots of floats by our pier. That is research on oyster aquaculture, helping promote oyster aquaculture. As you'll hear tonight, we help provide advice to states and jurisdictions in the region about sustainable management of fishery resources. We've done a great deal of work on recovery of seagrass, on understanding who eats who in the ecosystem, and we do things with environmental chemicals, such as evaluating the effects of sunscreens, for example, on environmental systems. This is who we are. We're a community of 94 people. Everyone in this community is essential, whether it is me as director or anyone on our facilities team. We cannot get by without the skills that every one of us brings. We get on remarkably well as a community, I think, because we have 20 buildings in which we're distributed. And if you don't like someone, they go to a building of their own. So we dominate the end of the island, for those of you who know Solomons, and we have very good relationships with the local community. So who are we today? What is our impact? So this is for this last year. So far this year, we've published more than 50 peer-reviewed scientific articles. We like talking to other pointy-headed scientists, but that's not our real impact. Our faculty have participated in 3 National Academy committees this year. The National Academy is instituted by President Lincoln to help solve the nation's thorniest scientific questions. And the fact that 3 faculty from a small institution in Southern Maryland serve on as many National Academies committees as we do is quite remarkable. Not only do we work for the National Academies, we work for organizations like the International Council for the Exploration of Seas, which is the primary research and management body for the entire North Atlantic Basin. Our researchers advise the International Whaling Commission on their policies. We serve, as I said, for the national academies. Our scientists head the California Bay Delta Independent Science Board. We serve on scientific and statistical committees in the federal management system. And more locally, we advise the Chesapeake Bay program. We serve on the Maryland Climate Commission, and we serve on the Chesapeake Bay Trust. Again, this is a tiny institution in Solomons that has the kind of impact that we do is quite remarkable. Last fiscal year, we raised $15 million in external grants and contracts. We were allocated $5 million by the state. That means for every dollar the state gives us, we turn back $3, which is a pretty good investment. We pay out in salaries to people living in this community about $3.2 million, equally shared between Calvert and St. Mary's County. So we have an impact in multiple ways in the community. We like to think we're connected to the community. The background picture here is of previous Science for Communities lectures in which one of my students came back to talk about turtles. I can see someone who was very much younger in the audience then, who's grown a little bit. We connect with the community through what we call citizen science. We have many thousands of people reporting dolphin sightings to us on a cell phone app that have informed tremendously on our knowledge about dolphins in the Chesapeake Bay. Why are they here? What do they do? What's the impact that they have? We also work with community members to measure nutrient pollution from septic tanks, one of the big questions about restoring the Chesapeake Bay. And then we welcome you to our community through the Science for Community lecture series. Prior to the pandemic, we held regular annual open houses, excuse me, where we attracted 500 to 1,000 visitors. We were exhausted by the end of the day, but also elated by the interactions that we had with members of the community. We typically have about 90 people attending each one of these Science for Community lectures, and we regularly go out into the community to talk to stakeholder groups in one form or another. I'm proud and excited by all of that, but I'm most proud and excited by the educational programs that we run. We train the future generation of environmental leaders. We train them not just in academic programs, but we connect them directly with management and policy decisions from the moment they join us. They are not in an academic ivory tower. They are on the ground doing real work with real world questions. And as always in any one of these, if anyone is interested in knowing more and supporting us, we would love to talk to you. For those of you in the room enjoying cookies and popcorn, we have the good people at Toyota Southern Maryland and Team Hyundai, and they've been long-running sponsors of this program. All right, so that's it. That's who we are. Now let's get to the meat of the question. So crab season canceled as officials investigate the disappearance of an estimated 1 billion crabs. Before you all think, oh, what's going on? I'll remind you that that's Alaskan snow crab, not our blue crab. But Alaska harvests 60% of the world's snow crabs. So if you like going to Red Lobster, I would leave at the end of this presentation and go straight there, because in a few months, if you think gas prices are going up, you wait till you see what happens to crab legs. So this is a big deal, and I say this, although I say it in a light-hearted way, I say it to emphasize that variability in crab abundance is not just something we struggle with. It is a common feature of any crab that's exploited in a fishery, because crabs are effectively weedy animals. They are designed to ride the environmental variation that the world provides by being highly fecund, by having huge numbers of offspring and taking advantage of the good times and just surviving through the bad times. So we're going to talk a little bit about that, and we're going to talk in much more detail about blue crabs and why we are concerned and what the potential reasons for the concern are and what some of the causes may be and what some of the solutions may be. So I spent a lot of my time thinking about blue crab, and I tried to boil it down to as simple a story as I can, but you're going to see lots of graphs, and I will try and walk you through all of them to interpret what they mean as we move along. So we're going to talk really about two sources of information. The first source are what we call surveys, which is where we as scientists go out and objectively estimate the number of crabs that are in the bay. We do that principally in the wintertime when blue crabs are associated closely with the sediments because it's too cold for them to be up moving around. And so they are stationary, and it is more like counting trees than it is like counting crabs that move. So we can be assured that a crab we count in the north of the bay is not the same crab that we count 4 days later in the middle of the bay or a month later in the southern part of the bay, right? It is going to be in the north and it's going to stay in. We do that survey with an oyster dredge, which works very effectively for crabs in wintertime. And we sample 1,500 stations each year we do this. Right? There are so many stations in this survey that I guarantee you, if I took the outline of the Chesapeake Bay away, you would still recognize that as the bay. Right? You could look and see where the Potomac River is here, where the Rappahannock River is. You could come over and see Tangier Sound and the Pocomoke River and the Choptank River. It's that many stations that it really covers the environment completely. And we count the number of crabs as mature females, mature males, and juveniles. And we've been doing that since 1990. And then the other information we have is catch data. These are the reports from individual watermen of how many crabs they've caught for every day that they go out. And again, fairly reliable data. So what do we do with all that data? All right, so here come the graphs. I'm going to spend some time on this one so you get orientated to them, and then I'll move through the other ones a little more quickly. So all of these graphs you're going to see at the beginning are an abundance on the vertical axis, typically in millions. So this is 300 million females, 250 million females. And on the horizontal axis is the winter in which the survey was taken. And 1990 is the winter that started in 1989 and finished in 1990. The abundance of crabs in that winter is shown by this single point at about 120 million female crabs. In 1991, that abundance went up, that abundance went up to about 230 million crabs. And so those 2 points are connected by a blue line. And now you can see the ups and downs over this first 28 years or so of the survey. Sorry, 18 years or so of the survey. On all of these graphs, I put a bright red dot where it is the lowest observed abundance for that type of crab. So in the winter of 1999, we observed under 50 million female crabs, and that's the lowest we have seen in the entire time series. We've never seen less than that, right? If I show a reddish box, as I show here, this is an abundance level that we don't think is sustainable, right? That's the background behind it. This is what the managers saw in 2008. And they said, we really don't like the fact that we've been at a consistently low level of abundance close to or below sustainability for the last decade or more. We want to change this. So they took brave decisions in 2008. Virginia closed the winter dredge survey. Maryland, the Potomac River Commission, and Virginia greatly restricted harvest of egg-bearing females, and they shortened the season. And lo and behold, we saw a really strong recovery, such that within 2 years, we were over 200 million crabs. And if you heard me give a Science for Communities talk at that time, I would have said, we've got this. And of course, nature always teaches you humility, because after that, it started varying again, right? So this takes us up to 2017, and you'll see it was variable up and down, but the average of this time series, shown by this purple bar, is at about 140 million crabs. So the management action had taken it from the 72.5 million in this earlier period on average to about 140, with approximately double the number of females. We weren't really worried by that variability because I said crabs are weedy, right? They take advantage of the good time and they hunker down through the bad time. So this is crabs taking advantage of the good times in 2010, whoa, and 2017. I have no idea what I did there. In 2017, taking advantage of the good time and just making it through the less good times in 2014. So from 2017 onwards, we see a pretty consistent pattern of decline in age 1+ females. So that we now have 97, or last winter, we had 97 million age 1+ females in the bay. That's part of the concern, not all of the concern. It's part of the concern, both the number and this 5-year continuous period of decline. Now, I said in 2008, the agencies took brave choices to manage largely female crabs. We ignored male crabs. So this is what male crabs have done over that time period, right? They were low in abundance in that period up to 2008, and they stayed low in abundance because we weren't conserving them. And male crabs now are at the lowest abundance we have ever seen, at 28 million crabs. So if you remember, 28 million, approximately 30 million, females 97 million, little over 90. So there are 3.5 or so female crabs for every male crab. And I'll come back to that point in a minute. This is concerning, but again, not set the alarm bells off concerning. This is the part that gets set the alarm bells off concerning. This is the juvenile crabs. This is who's going to be the next generation. And what we've seen in the juvenile crabs is really low levels of abundance in the last couple of years. And if you don't have juveniles, if you don't have babies, you're not going to have adults, right? So this low level of juvenile crabs compared to the low level of female crabs are the reason why, as a scientific advisor and the management agencies are extremely concerned about the status of blue crabs. Now, I've said that, but don't forget, there were 97 million females, about 30 million males, so we're about 130 million adult crabs and another 100 million juveniles. There are 230 million crabs in the Chesapeake Bay. We're not talking about extinction or extirpation, but we are talking about concerns for sustainability and concerns that the fishermen are not getting the maximum yield they could get out of the fishery. So this is the evidence for them not getting the maximum yield out of the fishery. This is the catch, right? Total catch in millions of pounds every year since 1990. In blue is the catch from the Commonwealth of Virginia. Yellow is the Potomac River Fisheries Commission. We separate that out because otherwise Maryland and Virginia will fight about it. So we give it their own little jurisdiction. and then red is the state of Maryland. And what you'll see from that picture is the harvest of crabs has really not varied very much over the last 20 years. It's between 40 to 60 million pounds of crabs a year. If our management strategy had worked, there would have been more female crabs, more male crabs, and they would have got higher harvest rates. So something about our management strategy is not working. All right. So I can combine those two and give us something else to think about. We know how many crabs there are at the beginning of the season because we count them in the winter dredge survey. And we know how many crabs were caught subsequently during the season. So if I take the number that were caught, divide it by the number at the beginning, I get an estimate of what fraction of the crabs were caught during the year. And we call that the next exploitation fraction. So the percentage of crabs that are caught in the fishery during a year, we can calculate that for male crabs, for female crabs, and for juvenile crabs. But because we're focused on females, I'm going to show you this for females. It's exactly the same structure of graph that I've shown you before, except the vertical axis now isn't abundance, it's that exploitation fraction. So it would be 0 if no one was catching any crabs, and it could conceptually go to 100% if every crab that were in the bay at the beginning of the season was caught. Now, we estimate that the watermen could catch about 37% of all the crabs, and as long as it was less than that, it would be sustainable. And we further provided advice to the states that as long as the fishermen were catching around 27% or lower, the fishery would reach maximum productivity. And you'll see that from 2008 on, the exploitation fraction has been lower than that 27%. There is no evidence here that the problems we are having with crabs is to do with overfishing. It could be that we provided wrong advice and there is actually overfishing, but not because the fishermen are catching too many, but because we provided bad advice. They followed that bad advice and had a bad outcome. But it is not as it is in so many fisheries that there is groups in the fishery ignoring the rules. I have never worked with a group of fishermen who are more interested in the long-term sustainability of the animal that they exploit than the people who catch crabs in this study. It is remarkable how passionate they are about the resource on which a large part of their livelihood relies. All right, now comes the graph no one likes, but I love it. So let's see why. Right? This is the spaghetti plot, right? I'll explain to you what it says to me and hope that you will like it too. So the bottom axis is female abundance. It's that graph I showed you that was low to 2008, went up, went down, came up, and has now gone down to 97 million. And it shows the lowest abundance as a red dot, just like everything else. The vertical axis is the exploitation fraction. It's the fraction that we catch. You can imagine if you catch lots of crabs, you would expect their abundance to be very low. And if you catch few crabs, their abundance should be very high. So this graph should sort of slope down from the upper left down towards the lower right, which is broadly what it does. There are two sets of lines on there. There's a red set of lines, which are like the guardrails. They are the levels that we don't think are sustainable. And there's a green set of lines, which we are provided the advice that is the target that we think the fishery should be trying to achieve. The dark blue points are the early part of the time series before 2008. The light blue points are after 2008. And just to orientate you, that's the point for 2021. All right. So now if you're staying with me, let's make it a little more interesting. There's two clusters of points generally on this graph. There's a cluster in the upper left shown by this sort of orangey colored circle up here, which is the area where we had concerns over the abundance and exploitation rate. Right? It was low abundance, high exploitation rates. That's this part of the graph in this orange circle up here. There's a point around this green cross that is high abundance, low exploitation rate. Up until 2021, we were at relatively modest abundance, relatively modest exploitation rate. In some senses, no reason for concern. You say, Tom, 2022 is not on this graph. It is now. Right? We don't know exactly where it will be, but we know it's 92 million crabs. We just don't know what fraction's been caught yet because the season isn't over. But if we say it performs much like it's done before, that's where the point will be. Right? It's gone back into that zone where we have concerns over sustainability. All right, so what's going on? That's the whole story, right? That's the crisis. Low female abundance, terrible juvenile abundance, and this concern that we've moved into this phase of crab dynamics that is not sustainable. So what's going on? You can see I had fun with PowerPoint. I can animate things. I've learned a great deal during the pandemic. So what's going on? The first thing that could be going on is that scientists, me, got the advice wrong, right? That we overestimated the productivity of the stock. So we've been asked to go back and reevaluate everything from the beginning. And that process is starting now. Right? It could be that the data are wrong. And in many fisheries, that's where the answer lies, right? That the survey isn't reliable or the catch data aren't reliable because the surveys don't cover the whole range of the species, or there's massive sort of black market sales of the species that isn't being recorded. We don't think that's the case in blue crab. We think the survey is one of the most reliable fisheries surveys there is. And we do not think there is sufficient sort of roadside market that's not reported to change the catch by a level that would be the size needed to change our understanding. So we don't think the data are wrong. So has something changed in the bay? Perhaps there are new predators. Perhaps the environment's changed. Perhaps the climate's changed. Right? So if it's one of those things, how do we look at those options? How do we explore that difference? So if you were the government and you wanted to know something about what the future of the US would be like, you would be really interested in the growth rate, in the birth rate, if you like, of the US as a whole. Because if the birth rate was high and the population was going up, you would have concerns about how we're going to feed these people. If the birth rate was high, you might say there are going to be lots of people entering the job market. That's a good thing. Or there are lots of people who need healthcare, and we need to change our provision of healthcare. Or there are lots of people going to be retiring, and we need to make provisions for those. Right? So when we plan, we look at birth rate. And in general, if you think about it, a birth rate has to be at least 2 children per mother to replace the mother and the father. Right? If the birth rate's higher than 2, the population is going to go up. And if the birth rate is lower than 2, the population is going to go down. So I would argue that understanding the birth rate in blue crabs is the most central management question we have. And we have to ask, is the pattern in birth rate dependent upon what we're doing for management? Is it being affected by a new predator? Is the environment changing so rapidly that the birth rate's been affected? Is the climate change so rapidly that it's being affected? So how do we calculate the birth rate? All right, this is our friend the winter dredge survey. You know it's conducted every year, and you know that we estimate the number of age 0 crabs, such as in the winter of 2020. We estimate the number of age 1 females in that winter, and the number of age 1 males in that winter, and we do it in 2021 and we do it in 2022. So if you look at the abundance of age 0 crabs in the winter of 2020, they will grow up and they will become the age 1 plus adults the next year. And the age 0 crabs in the winter of 21 will become the age 1 plus adults in the winter of 2022. Right? You've seen me call them 1 plus all the time. So if we really want to be important, we have to recognize that some of those age 1 females survive to become age 2 females or age 3 females. Right? And so they've got lots of arrows on the graph. That's how we calculate the stock assessment. That's what all the stock assessment is based on, those blue arrows moving through time. But I'm going to say we need to look at things a little bit differently. Those age 1 females in 2021 are responsible for the age 0, those age 1 females in 2020 are responsible for the age 0 crabs in 2021, and the age 1 plus females in 2021 are responsible for the age 0 crabs in 2022. And those yellow arrows are births and survivals, right? So I can very easily calculate the birth rate. The birth rate for 2020 is the number of age 0 crabs in 2021 divided by the number of age 1 females in 2020, or the birth rate for 2021 was the number of age 1 females in 2021 divided into the age 0s in 2022, right? You get the picture. So I can do that for the entire time series of the Chesapeake, of the winter dredge survey. And of course I have. So here's the graph, right? This is the effective birth rate for blue crabs over that entire time series. I've calculated the average between 1990 and 2008, and it's 2.24. I've calculated the average for 2009 to 2022, and it's 1.34. And that 1.34, remember what that means, less than 2, so they're not replacing the mother and the father crab that gave rise to the offspring. That 1.34 is driven largely by these last sort of 4 numbers or 5 numbers in the last 6 years. This shift in birth rate, particularly since 2017, is what's driving all of this concern. So we have to ask what's going on from 2017 that has caused the birth rate to go down. All right. So what could cause a low birth rate, right? Remember, this is the number of offspring next year divided by the number of adults this year. It's a rate, has nothing to do with the number of females, in the sense that a low number of females can still have a high birth rate, right? And a huge number of females can have a low birth rate. So it's not related to the number of females, it's a rate. So what could it be related to? So it could be caused, some of my colleagues have suggested that it's caused by a biased sex ratio. I told you, we've increased the number of females, but left the number of males unchanged, such that there's a little over 3 females for every male. And there's some concern that there are simply not enough males to inseminate the number of females that are there. So their reproductive capacity has gone down. They are not receiving the sperm that they need to reproduce. And there are particular reasons in crabs why that's important, because female crabs store sperm. They mate only once, and they carry all of the sperm they receive at that mating to produce a number of broods afterwards. So a female crab mates once, she gets enough sperm for perhaps 9 broods over the next 2 years. And at every brood, she can produce 5 million new crabs. So 9 times 5 million, every female is producing 45 million new crabs. We should be walking from here to Crisfield on the back of crabs. But you only have that many crabs if most of them are going to die. And that's the fate of a baby crab. The average baby crab is dead. It's the exception that survives. And there are some of my colleagues who suggest this bias-sex ratio is behind it. Some have also suggested that smaller females have fewer eggs and that females are smaller. Colleagues of ours from the Morgan State University Pearl Lab just up the river on the Jefferson Park Museum campus have been monitoring crabs in the Patuxent River and in nearshore Chesapeake Bay for many, many years. And they've shown evidence that the largest females are much rarer now in the population than they used to be. Why is that important? Because the number of eggs a female has is directly related to her size. If she is about 100 millimeters, so just under legal size, she'll have 1 million eggs. If she's 200 millimeters, a good sized female crab, she'll have 5 million eggs, right? And it varies almost linearly between. So if you reduce the size of the females, you reduce the number of eggs that she has. The same number of crabs, smaller crabs will have fewer eggs than larger crabs. All right. So female characteristics could be that's to do with, if you like, the number of offspring produced. What about the survival of? Could low birth rate be the result of low juvenile survival? So many of you here know the life cycle of the blue crab better than I do, but it starts, we'll consider it, with the male cradling the female in the soft shell stage, transferring sperm. Again, remember, transferring enough sperm for her to have perhaps 9 broods over the next couple of years. She migrates down to the lower part of the bay, and in the summer, she'll move to the very mouth of the bay, and the offspring that she's been carrying as a sponge on her abdomen will be released as zoea, which are shrimp-like looking things, less than 1 millimeter in size, and they go off into the Atlantic Ocean, where they spend the first 6 weeks of their life before they metamorphose into this thing called a megalopa, which looks a bit like a demented lobster. It's the first stage that has claws. They come back into the bay, settle in seagrass and other structured habitat, and then distribute themselves throughout the bay. So let's look at that 6 weeks or so when they're offshore, and they're living in this environment. This is a NOAA satellite image of sea surface temperature in the coastal Atlantic. That big red stripe running from the bottom left towards the upper right is the Gulf Stream. It's this river of warm water that's moving northwest that kept me warm as a child. And all of this different color in here is different currents mixing. And the crabs have to navigate all of that. And this ocean is changing rapidly as it walks. And so perhaps people say the currents offshore are changing, and so fewer crabs are getting back into the bay. So even though females may be having the same number of offspring, fewer of them are getting back into the bay to survive. All right. Some may say, but juvenile crabs are surviving, but when they get back in the bay, there's nowhere for them to settle. Right? We have not produced enough submerged aquatic vegetation, or SAV, for them to settle in. This is the history of estimates of SAV abundance since 1984. And you'll see that in the period we're interested in, from 2008, it's varied a bit. And you could perhaps make a case there's been a dramatic drop from 2018 to 2019, probably due to that strong freshwater influx we had in that year, but perhaps not enough to explain the dramatic change in juvenile survival. Well, perhaps they found somewhere to settle, but something's eating them. And the usual thing that's pointed as the culprit is blue catfish. This was introduced by fishery managers in Virginia because they grow really big. They're an enormously popular sport fish. 90 pounds for a blue catfish is not uncommon. What does a 90-pound blue catfish eat? Anything it wants, right? This is the sort of thing you don't let your dog go swimming with a 90-pound blue catfish around. The question is, have they spread wide enough, and are they voracious enough predators to explain the low survival of juvenile crabs? And they've certainly spread wide enough. In the late 1990s, I was doing surveys of the Patuxent River, and there was not a blue catfish in the river. You go out in the Patuxent River now and do a survey from sort of St. Leonard Creek up to above the Benedict Bridge, it's almost nothing but blue catfish. They have completely changed the ecosystem, utterly changed the ecosystem. But crabs don't occur just in the tributaries, and generally, blue catfish are most abundant in the tributaries where they prefer lower salinity water. So there's a lot of uncertainty over blue catfish, a lot of uncertainty of how much they eat. In surveys in rivers in Virginia, people find that somewhere between 2 to 6% of all the blue catfish they sample had blue crabs in them. And the fraction of the diet that blue crabs comprise in those blue catfish is somewhere between sort of 2 to 7%. So evidence certainly that blue catfish eat them, perhaps not enough to really change the dynamics. All right, they're not growing fast enough because they don't get big enough during the summer because their prey resource is down and they die in the winter time. But as many of you have seen our climate stripes around the corner, winters here are getting warmer. Winters are getting shorter. Winter's water is getting warmer. When Truitt founded the laboratory, crabs went into their dormant phase in early December, came out in late March, early April. Now they don't go into their dormant phase until late December, early January, and they come out in early to mid-March. Winter for blue crabs in the last 70 years is a month or two shorter than it was. So it is highly unlikely that overwintering is the smoking gun. Is their prey declining? Is the ecosystem changing? With colleagues, Don Liang and Mike Wilberg, we looked at all of this together, trying to understand how does discharge from the Susquehanna and wind speed and summer water temperatures and summer salinities and the hypoxia in the water and predators and SAV affect the abundance of age 0 crabs. And the only things we find are statistically significant are that age 1 crabs increase the number of age 0 crabs because they're parents, right? They're producing the next generation. But summer surface salinity decreases the number of age 0 crabs, suggesting this broad climatic control over crab abundance. But I know there are important data gaps related to predation and perhaps related to many of the other factors. So these results are by no means definitive, nor do we have clear understanding of the mechanisms behind these correlations. All right, so let's wrap it up. Crisis in crabs. The crisis, as you've heard, is 97 million females, low level. Lowest abundance of males on record, 28 million. One of the lowest abundance of juveniles we've ever seen in the last 30 years. Birth rates below 2, but I've told you it's probably not overfishing, and I've suggested multiple possible explanations. All right, now we're going to bring the story full circle. possible explanations. Female size and sex ratio. They are the only two that respond to traditional fisheries management. Fisheries managers change the number of crabs people can catch and the size of those crabs. That's all they can do. So the only ones that fishery managers control are female size and sex ratio. Many of the other explanations, predation, water quality, and climate, aren't under the control of fisheries managers. To manage crabs with those factors would require an integrated ecosystem-based approach. And who had that idea? Truett, almost 100 years ago. And that's why Truett stands as one of the environmental giants who is completely unrecognized. He was thinking this way 100 years ago, and that is utterly, utterly remarkable. So that's my story for tonight. I'll be happy to answer any questions either that have come in the chat. And remember, it's not the crabs think we walk sideways. And any questions from the room, I greatly appreciate your attention. And I can't tell you how good it is to be standing in front of the live audience as well. So thank you very much. I will try and alternate a question from the room and a question from Zoom. So let's start with the room. Questions, thoughts, comments, jokes?
Well, are there plans then, the two items that you can manage? Are you putting in recommendations in that regard?
So the fishery management agencies have adopted cautious regulations this year. If the winter dredge survey is as bad as many feel, I think you will see emergency regulations going in place that will affect size limits and abundance. With particular effort, I think, to try and conserve, we've put so much effort in conserving female crabs. I think you will see an effort into conserving male crabs to try and adjust the sex ratio. Right? So there are people who are as concerned about this as they should be, standing ready to act. But because we don't know the real cause, people just want to get a little bit more evidence, I think, before they do act. All right, let's see what our friends on Zoom said. Is there anything that the public can do to help increase the chances for juvenile crabs to thrive? Great question. Probably not is the answer, right? What are the things you can do directly is the probably not. The things you can do are continue to advocate for restoration of submerged aquatic vegetation, restoration of habitat, improved water quality. And I assure you, the watermen are advocating for that too. This is not one side against the other. They know full well that a better habitat will give them a more sustainable fishery. But that's the role at the moment of citizen advocates. Another question from the room. Ma'am.
Hello. So how can the blue catfish be regulated or monitored so that they're not?
Right. So the question was, because it probably didn't carry to the audience, the question was, how can blue catfish be regulated? So blue catfish already supported until very recently, a multi-million-dollar fishery. The reason they no longer support one is that the FDA decided, Food and Drug Administration, decided that they should regulate all catfish harvests because they thought the only catfish that was being harvested was aquaculture, sort of pond-grown catfish, and there was a huge influx of pond-raised catfish from Southeast Asia coming in. So the FDA said, we're going to have to regulate it all. And no one really said anything until the fishermen suddenly realized that they had to have an FDA inspector in every plant that was handling catfish, and there just weren't enough around. So until recently, blue catfish was a multi-million-dollar fishery. And I would suggest the evidence is that if we want to overfish a species, we're entirely capable of doing it. Right? You think about cod, you think about the history of striped bass, you think about sharks, you think about whales, we're really good at overfishing things. And so I would suggest that the control for blue catfish is to promote fisheries. And if you've not tasted blue catfish, it's pretty good. Another one from the Zoom audience, check I didn't. Is having a dual size limit, not only a min, but a max for females, a realistic option? So realistic from a practical point of view, yes, right? Crabs are, again, fairly unique, not just blue crabs, but crabs in general. You can take them out, you can sex them quickly, you can measure them quickly, and you can put back those that are outside the legal limits. That's what happens in lobster fisheries, right? If you get a female of a certain size, or one that has evidence of having spawned before, they cut a notch in the tail of the lobster and they let them go again. Right, because that's a successful breeder and she will probably breed again. And so there is the potential for some creative ways of managing blue crab with what we call a slot limit that could say up to this size, you can't harvest them, and bigger than this size, you can't harvest them, but you keep the ones in the sweet spot in the middle. We haven't done enough work on that to be able to advise the agencies what those limits would be. But that's a great question. Someone else from the audience.
So there are blue crabs in other parts of the country. Is the situation unique to the Chesapeake Bay? Is there any comparison of data from other blue crab populations?
So this is why I love giving these talks in public, because we get such great questions. The question was, blue crab are widely distributed. They occur from commercial fisheries from New York all down the Atlantic coast through the Gulf of Mexico into South America. And the question was, are there similar problems with other fisheries that might suggest this is not a Chesapeake Bay problem, this is a coastwide problem? The last time we looked at that was in 2014. And at that time, there was clear evidence that the patterns in our fishery are similar to Delaware and similar to New Jersey, but different from North Carolina. As in many things, Cape Hatteras, where the Gulf Stream suddenly diverts off the coast, is an important province. It marks South Atlantic species and fisheries separate from Mid-Atlantic. So that's where we would start, looking at Delaware and New Jersey and expecting those to be more similar to the Chesapeake and different from what's going on in North Carolina and South. But I can't answer your question, and it's a great one. All right. So did you say you think the blue catfish is not a big problem for crabs because crabs are only 2 to 7% of their diet, or do I understand wrong? Barbara, another great question. I said the data that we have on the catfish that have been looked at in 4 rivers in Virginia tend to suggest that they are not a huge predator. But the size range wasn't particularly wide, and it wasn't wide geographically. So I wouldn't say that they are definitively not an important predator, because the minute I say that, someone's going to release a study that shows that they are. But the early evidence suggests that they are an important predator, but perhaps not the really big threat. And there's sort of nothing that would suggest why blue catfish became this important predator in 2017 when the birth rate really dropped, right? So that part is sort of disconnected. So
is there any evidence that the crabs themselves are adapting to some of these stresses, whether it's temperature or salinity or different pollutant level?
Great question. Question was, is there any evidence that crabs are in some way adapting to this changing environment? I think one of the things this crisis has taught us as a research community and as a management community, to some extent, we've taken our eye off the ball a little bit. We thought we had blue crab right where we wanted them, that we understood the system, and lots of attention switched to oysters and striped bass. And so there's not been a huge amount of research on the sort of ecological adaptations that blue crab might be changing to. And for many species, you see very dramatic flip-flops as the environment changes. It's not, we tend to think that environmental change is steady and the animal adapts steadily. And that tends not to be the case. It tends to adapt in a short period of time, very rapidly and change, often involving a change in behavior, for example, a dramatic change in behavior. And there's not been research that would suggest or that would indicate that that sort of thing is yet going on. But a great question. Is there any chance that part of the change in birth rates is due to the spread of blue crabs to Europe? So Rose, my daughter, didn't ask the crabs eat walk sideways question, but did ask a great question all the same. If you're not aware, we think of blue crabs as great. If you go to the Mediterranean, they don't think that's so great. And they have spread from being accidentally introduced in the area around the mouth of the River Nile and have spread throughout the Mediterranean and now progressing up into the Bay of Biscay and up the English Channel towards Denmark and other. So that is a case of an invasive species spreading. It should have very little to do with the birth rate here because it is not crabs from here moving over. It is crabs that got moved over, probably in ballast tanks in ships, just finding an environment that does suddenly the new kid on the block and are doing great things. I'll take one more question from here because it's 8 o'clock. I will happily stay on afterwards, but one last question, sir.
How much geographic variability have you seen in your Chesapeake Bay surveys? We've seen in the St. Mary's River, we're monitoring 22 sites in the river for salinity, temperature, dissolved oxygen. We've seen in the last year or so, the pot catch at our pier has doubled or tripled.
Yeah.
One of the things we've seen in that data is that the bottom water in the river has gotten more hypoxic, much more, like 1% or 0.1%, to within 10 feet of the surface. We've moved our pots into 3 or 4 or 5 feet of water, and we're catching huge numbers of crabs.
So what you see, you heard me respond about a behavior change, right? Small changes in the environment gives you big behavior changes. So you think of the crabs being evenly distributed across the Chesapeake Bay, and are not. They're constrained by appropriate water temperatures and appropriate levels of dissolved oxygen. And if that level with appropriate dissolved oxygen becomes squeezed onto the channels, then in fact the blue crabs become more vulnerable to the fishery, perhaps more vulnerable to herons, perhaps more vulnerable to other predators, because they're being concentrated into a smaller and smaller part. That becomes so severe that you may have heard of events called crab jubilees, where the low oxygen comes right up to the edge of the water, and the crabs literally walk out of the water because they can't live in the low oxygen water. They have no choice. So you do see this habitat squeeze being caused by poor water conditions, changing the distribution of crabs and changing their vulnerability to sources of more mortality.
I shouldn't have brought that up. We'll have more damn crabbers in our river.
Pretty hard to set crab traps in 3 feet of water. First of all, thank you all for your attendance tonight in person. Thank you all for your attendance on Zoom. I encourage you to come back next week, either in person or on Zoom. Listen to Dave Secor talk about Atlantic sturgeon in the Marshy Hope Creek on the eastern shore, the only spawning site for Atlantic sturgeon in the state. And if you have any questions, do not hesitate to contact me. I welcome questions from anyone, and I will do my best to answer all of them. So thank you very much on Zoom. Thank you very much here in the room. We'll see you all next week.